Hi girls. So just recapping over what we were doing the other day. So we had looked at sets. Okay, we had done some basic questions from the book on page 41. We looked at questions 1, 2, 3 and 5 and I corrected these during class time. Some classwork for today, and it's starting to take a little bit of a step up. Some of these questions are a little bit harder than normal. So question 8 is straightforward. Okay, so you've seen all of that stuff before. You're just answering the questions based on the Venn diagram that's given. Question 12 is where it's starting to get a little bit harder because you don't know how many students are in each one. And they've given you a hint and they're telling you let X be the number of students that are in B only. Now I will be doing this in the live class showing you how to do it, but I'd love you to take a go at it first. So far questions 8, 12. On the opposite side of the page, I'd love you to do question 15. And again, you're using X, this is a number that you don't know, in the intersection it's telling you, to find a value for each of the sections in the Venn diagram. And the last question we're going to do is question 17. So just to write that out for you. So on page 42, you're going to do questions 8 and 12. On page 43, you're going to do questions 15 and 17. And now I'm just going to go through the teaching part of the class, so the new information. For this should be taken down in your notes copy. Okay, so you can take out your notes copy now. And I'm working on set difference on page 43. So in this section, we're going to introduce a new term called set difference. To illustrate set difference, if you take the two sets, A and B, okay, A is 1, 2, 3, 4, 5, 6, B is 4, 6, 8, 10. If we remove set A, that means all of these elements, if we remove all of A that are in B, we have A less B. Okay, so if we remove from set A all the elements that are in B, apologies, so if we take out any of these numbers that are inside there, we have to rewrite out the set. Okay, so A less B. So we want to write down what A is, taking out 4, 6, 8 and 10. Now we don't have 8 and 10 in set A, all we have is 4 and 6. So we're going to rewrite A without 4 and 6. And it's going to be 1, 2, 3 and 5. So set difference in your copy will be A less B is a set of elements of A which are not in B. So what I'd like you to write in your copy, your title is set difference. It's kind of like complement in one sense. So set difference is A is 1, 2, 3, 4, 5 and 6. And again, don't forget your chain brackets. B is 4, 6, 8 and 10. And I'm just going to show you in a diagram what that would look like. And again, I'm just going to show you using a ruler to draw the actual Venn diagram. Okay, so what I'm drawing at the moment is a universal set. And I've drawn A and B. And what's common to both of these is 4 and 6. So you'd always put in what's common to both first. So I've eliminated 4 and 6 from each one. So in A, there is 1, 2, 3 and 5. And left in B is 8 and 10. Now, A less B, that's how it's written. A less B. What you need to do is write what remains in A when B is removed. Okay, so that's what you're doing. Write what remains in A when B is removed. You're covering B. So I'm just going to put my finger over B. That's what B is, and I'm just going to label that because I haven't actually labelled. Cover B, and you write down what's left in A. So A less B is just when you cover B, what's left in A. So my answer for A less B is equal to 1, 2, 3 and 5. People get confused with this notation as opposed to A complement. But A complement is slightly differently. Oh, sorry, B complement. When you take out B, you actually write if there's numbers on the outside here as well. Okay, so that's the difference between B complement and A less B. B complement is you take out B, but you write everything else. So it's all of these numbers here, but you could have numbers on the outside, okay, in the universal set. Whereas A less B is just talking about these two things, and you take out B from A and you tell me what's left. Okay, and that's the difference between complement. B complement is not the same as A less B. Because you would need to write the other elements outside of the Venn diagrams. I'll give you an example. Let's say you had, I don't know, 9 outside there. Okay, for B complement, it'd be 1, 2, 3, 5, and 9. Whereas A less B is, you're looking at these two things and you're just taking out B from A and you're telling me what's left, which is 1, 2, 3, and 5. Okay, so that's what set difference is. And you've this taken down in your notes copy neatly. Okay, and I know you can't actually see that. So set difference, A less B, is when you write down what remains in A when B is removed. So just cover B and you're writing down what's left in A. And I've written it down 1, 2, 3, and 5. B complement is not the same thing as A less B because you would need to write down the other elements outside of the Venn diagram. So if I had the number 9 or even 12 outside of the two Venn diagrams and I did B complement, yes, means take out B and you cover B, but you need to write everything that's left. Okay, and that's the difference between both. Pop back to the book, okay, and turning over to page 44. So yes, I have done kind of a little sketch of this. So A less B means you cover B and you write down what is left. B less A means you less A, that means you cover A and you write down the numbers that are left in it. Okay, and the difference between the complement and set difference I've kind of explained already. I'm going to do example 1, but when it comes to Venn diagrams or even sets, it's easier when you see a set actually drawn out. It makes it easier to visualize. So just in your book, I'm just going to, and you are going to take this down, example 1. And you can do this in your copy, it's not in your notes anymore. Okay, so I'm just going to draw the Venn diagram again. So there is A and B. And as I've explained to you a few times already now, the easiest thing to put in always when you're given two lists of letters is you put in what's in the middle. So we'll see what's common to both. So EFG is common, H and I isn't in either. So EFG is common to both. So that's what goes in the center. E, F, and G. What's left then in A will be A, B, C, D. And then what's left in B is H and I. Okay, so that's it. You're then asked in the question, find A less B. When you less B, you take out B. So you're left with A, B, C, and D. And again, you're putting that in the chain brackets. Okay, so that's A less B. Part 2, you were asked for B less A. And again, that means just cover A and you write down what's left, which is H and I. Part 3, this looks terrible, but A union B less A intersection B. Okay, so it's asking you to remove the intersection and then write down everything else. That's what that means. A union B is everything, but you're lessing the intersection. Cover the intersection and write down everything else. So, and again, going from smallest to biggest, A, B, C, D, H, and I. So, although that looks more complicated than it is, A union B is everything. So you look at everything and then you remove the intersection of A and B, which is the bit in the middle. Cover it and you write down everything else. Okay, so that is the example from your book. Investigation then, and this is just you getting used to the notation that's in questions. Copy and complete the following table by describing the words and where possible in symbols for each set of numbers below. So Z less N, that means the set of integers, all of the integers minus the natural numbers. So it's essentially all the negative numbers including 0. That's what you're including. Z union natural numbers. This is a set of integers including all of the natural numbers. So it's all the positive and negative whole numbers including 0. The intersection are the numbers that cross over. So these are a set of natural numbers because if it has to include the intersection, it's all the natural numbers. So 1, 2, 3, 4, all the positive whole numbers excluding 0 and so on. So you're just kind of getting used to the notation. That's what that is. On Monday next, we're going to look at the commutative and associative properties. We're not going to worry about them just yet. What we've looked at is set difference and you getting used to doing A less B and B less C and so on and so forth. The best thing I would suggest to you is if you draw out the Venn diagram first, it's just easier to cover a diagram when it's there in front of you as opposed to trying to look at numbers and that and then trying and see what's common across the board. Just from this, we're going to do questions 1 and 2. Okay. So at this stage, I've given you a list of questions now. So I'll just remind you. So it's page 42, questions 8 and 12. And I was saying 12 in particular is a little bit more difficult. Page 43 is questions 15 and 17. And finally on page 45, it's questions 1 and 2. Now, question 3 and 4 is also kind of just a continuation of it. Some people in class are obviously going to have these done while I'm explaining how to do them. And if you do finish early, you can do question 3 and 4. Okay, and that's what we hope to get done during class today. So once you have the video fully watched, you understand what set difference is and you've taken that into your notes copy, you've taken then the example, you're then going to your book and copy and you're starting on these questions and you're going to join me live now.